Hey everyone, welcome to Hub 360 Embedded Sphere. In today's video, we are building a wireless temperature and humidity display with an RF module using two Arduino Unos, a DHT sensor, and a 433 MHz RF transmitter and receiver. The temperature and humidity readings will be shown on an LCD display. Here is what you will need for this project: two Arduino Unos, one DHT sensor, 433 MHz RF transmitter and receiver, 16 by 2 LCD display, jumper wires, and your breadboard. Okay, now let's do the circuit for the transmitter side. Place the DHT sensor on the breadboard. Connect the VCC pin of the DHT to 5-volt pin on the Arduino. So we'll be connecting it to the positive rail of our breadboard first. Connect the ground pin of the DHT to the ground of the Arduino, which is similar to connecting it to our negative rail. Then connect the data pin of the DHT to digital pin 5 on the Arduino, and we have to use our resistor. So we are connecting the other end of the resistor to positive rail of the breadboard. So we are done with our DHT. So to connect our 433 MHz RF transmitter module to the breadboard, so connect the VCC of the transmitter to 5 volts on the Arduino. That is the positive rail of the breadboard. Then connect the ground. To the negative rail of the breadboard. Then connect the data pin of the transmitter to digital pin 12. That's it for the transmitter. This setup will read data from DHT sensor and wirelessly send it, where we'll connect the ground of our Arduino to the ground of the breadboard, and the 5 volts of our Arduino to the positive rail of the breadboard. Okay, now let's go to the receiver circuit. Place the 433 MHz RF receiver module on the breadboard. Connect the VCC pin to 5 volts of the Arduino. Connect the GND to GND. So we'll be connecting it to the negative rail of our breadboard. Then connect the data pin of the receiver to digital pin 11 on the Arduino. Now take your 16 by 2 LCD with I2C adapter and connect it to the Arduino using jumper wires. Connect the GND pin of the I2C module to the GND on the Arduino. So we'll be connecting it on the negative rail. Connect the VCC to 5 volts. Connect the SDA to A4 and connect the SCL to A5. I'm connecting the ground of the Arduino to the ground of the breadboard and the 5 volts of the Arduino. Let's take a look at the transistor code. We begin by including the necessary libraries dht.h, rh_ask.h, and spi.h. Here's what each library does. The DHT library allows us to interface with the DHT sensor, making it easy to read temperature and humidity values using simple commands. The Radiohead ASK library handles amplitude shift keying communication, which is the modulation technique used by 433 MHz RF transmitter and receiver. It takes care of sending and receiving message reliably. The SPI library is included, even though we aren't directly using any SPI based components. This is because the Radiohead library internally depends on SPI for certain low level functions, even when using ASK mode. Then we have the pin connected to DHT sensor and specify the sensor type as DHT11. We specify the sensor type as DHT11. Then we also create two important objects, DHT sensor object and the RH_ASK driver. So for the DHT object, it initializes the DHT sensor class, allowing us to easily access temperature and humidity readings using simple functions. Whereas for the driver, this set up the RF transmitter driver using the Radiohead ASK library, enabling the Arduino to send message wirelessly. Make sure you have these libraries installed if you haven't already. To install these libraries, open Arduino IDE, which we have done. Then you go to Sketch, include library, or you can just come to Library Manager. Then you type DHT. Search for DHT sensor library. You see DHT sensor library by Adafruit. This is it, DHT sensor library by Adafruit. Then the next one, Radiohead. Um, Search for Radiohead. Look at it here by Mike. Yeah, so that is it. Then we go to the void setup. So we have serial.begin 9600. It starts the serial monitor for debugging. We have driver.init, initialize the RF transmitter module. There is dht.begin, initialize communication with the DHT sensor. We also, for our main loop, we add a short delay before taking a new reading, giving the sensor time to stabilize. Then we also have float temp because DHT does read temp, and same with the humidity. So the first one reads for temperature in Celsius, whereas the second one reads for humidity as a percentage. Then we have check if reading is valid. Is NaN temp or is NaN hum? Is NaN check if the sensor return a valid number. If not, it print an error and exits the loop. Then we have serial.print temp and serial.print hum. These lines print the raw temperature and humidity values to the serial monitor for testing and verification. Inside the loop, we read temperature and humidity from the DHT. If the reading is valid, we format the values and send them as a string, like 25.4, 60.2, all inside an arrowhead. Yes. Now let's look at how we prepare and send the temperature and humidity value. We have char MSG, which is 20. We start by creating a character array named MSG with a size of 20 bytes. This array will temporarily store the formatted message that contains both the temperature and humidity values. It's important that it's large enough to hold the entire message, including symbols like angle bracket and commas. Then next, we format the message into a specific structure This is the snprintf. Snprintf is a function that safely writes formatted data into a character array. It, it's often used to build strings by combining variables and fixed text in a controlled way. So for our function, it takes the following arguments: destination, size, formatted string, value to insert. So that is it. So for the destination, this is where the final string will be stored. In our case, that's the msg array. Then we have the size, the maximum number of characters to write, helping prevent buffer overflow. So we gave it 32. Then we also have formatted string. This contains the structure and format specifier. Like we have ampersand s for string, ampersand d for integer, and the rest. But now where we are, since we are sending it in string, they are both percentage s. Yes. Then we also have for the temp str and the home str. These are the actual values that replace the format specifier. In our case, temp str, which we've made mention of. Then we have for here we have serial.print msg, which display the full formatted message in the serial monitor. We have driver.send. It transmits the message over the RF transmitter. We cast the message msg with uint 8 underscore t. Yes, because the library expects byte data. So lastly, we have driver.wait packet sent. What does it do? It wait until the message has been fully sent before continuing. Then we have delay 1000, which adds a 1 second delay before taking the next reading and repeats the loop. And that wraps up the transmitter code. With this setup, the Arduino reads temperature and humidity data from the DHT sensor, format it, and send it wirelessly to another Arduino using an RF transmitter. Now let's move to the receiver code. We include the necessary libraries, including the liquid crystal underscore I2C library to handle our LCD. We've already explained the RH underscore ASK library in the transmitter code. It's the Radiohead library and it enables wireless communication using the ASK, that's the amplitude shift keying protocol. In this case, it's used to receive the data sent from the transmitter over the 433 MHz RF module. Now let's talk about the liquid crystal underscore I2C library. The library allows us to control a 16:2 LCD display using an I2C interface. I2C drastically reduces the number of pins required to connect the LCD to the Arduino. It uses just 2 wires for this, which are SDA and SCL. Make sure to install this library if you haven't already. To install this library, open the Arduino just the way we did for the previous one. Go to the library manager, search for liquid crystal I2C, and install any version that works with your LCD. By Frank de Brabanda. Let's move on to the setup function now. We have serial.begin 9600. This starts serial communication at a baud rate of 9600. Then driver.init. This sets up the RF module using the Radiohead library, so it's ready to receive data wirelessly. Then we have lcd.init and lcd.backlight. So lcd.init initialize the I2C LCD module, while lcd.backlight turns on the LCD's backlight so the characters are visible. After that, we prepare the display by clearing any previous data. That's for the lcd.clear. We clear the screen, set the cursor to the first row and column, and print a welcome message. This is just a friendly message to show the system is starting up. Finally, we add a short delay to let the message stay visible for 2 seconds. That's delay 2000. Then we also add lcd.clear. Now let's move to the loop. On the loop function to the receiver. This is where the Arduino constantly checks for incoming RF data, processes it, and display it on the LCD. We start by creating a buffer to hold the incoming message. 8 underscore T buff, which is 20. Then we have buff length which is equal to size of buff. Yeah, buff is a byte array where the received data will be stored, and buff length holds the length of that array. Next, we try to receive the data using the radio head driver. This is the if driver.receive. If data is successfully received, the block of code inside the if statement executes. That is all this executes. Um, that's for our buff length. We have char temp to be 6. We set the size to be 6. Same with home string. Here we add a null terminator at the end. Look at it. We add a null terminator at the end of the message to ensure it's treated as a valid string. Then we cast the buffer to a char star and print it on the serial monitor for debugging, which is here. Now we extract the temperature and humidity values from the message char temp str6 and char home str6. We are using strncpy, which is for string copy, to copy 4 characters from the message string into 2 separate strings. One for temperature and one for humidity. The +1 skip the opening angle brackets character, and the second line ensures both strings are properly null terminated. Next, we convert those string values into float numbers. We convert them into float numbers. This is it. Temp is equals to a to float, and ATOF, which is to convert it to float. Then the ATOF, which stands for async to float, to convert the extracted string values into float variables we can use. Finally, we display the data on the LCD, which is set cursor 0, temperature, temp, and char 223, and the rest. We print the temperature on the first line of the LCD, adding the degree symbol using char 223 and appending C for Celsius on the second line. We show the humidity with a percentage sign at the end of the loop with delay for 1 second. This gives the system a short pause before checking for a new data again. Connect the Arduino that has the DHT sensor and RF transmitter module to your computer using a USB cable. In the Arduino IDE, open the transmitter code. Make sure the correct board and port are selected, then click on Upload. Next, connect the second Arduino, the one with the RF receiver and LCD display, to your computer. Open the receiver code, select the right port, and click on Upload. Just like before, the Arduino will start listening for data sent from the transmitter and display the temperature and humidity values on the LCD. If everything is working correctly, you should now see real-time temperature and humidity readings showing up on the LCD screen connected to the receiver every second, and the receiver updates the LCD accordingly, as seen below. And that's it. You've successfully built a wireless temperature and humidity display system using 2 Arduino Unos, DHT sensor, RF modules, and an LCD. As you can see, the temperature and humidity readings are wirelessly transmitted and displayed every second. This project is a great way to get hands-on experience with wireless communication, sensor integration, and LCD display handling. You can find all the components used in this project along with the link to the Hub360 website, where you can purchase them, in the description box below. The complete code and freezing circuit diagram are also available there to guide you step by step. If you found this helpful, be sure to like, subscribe, and turn on the notification for more Arduino projects. Thanks for watching, and I'll see you in the next one.